Hello, and welcome to Backer Breaks It Down. In this episode, we are going to find some exact values using sum and difference formulas for sine and cosine. So here we have our four sum and difference formulas for sine and cosine, right? So you've got sine of a sum, alpha plus beta, and this can be expanded to be sine of alpha times cosine of beta plus cosine of alpha, sine of beta. Now the sine of a difference formula, the difference between alpha and beta, becomes sine of alpha cosine beta minus cosine alpha sine of beta. We have sum and difference formulas for cosine as well. So cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta, and cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So I think what you should notice about all of these is that they involve two angles, alpha and beta. And so what that means is that you will have to draw two reference triangles, one for angle alpha, one for angle beta, okay? That's where you're going to get the values of sine alpha, cosine alpha, sine beta, cosine beta. It's from those reference triangles, okay? So in problem number 1, we want to use a sum or difference identity to find the exact values of cosine alpha, cosine beta. So first we have to draw two reference triangles. Now they tell us that sine of alpha is 4/5, and that alpha is in between 0 and pi over 2. So what that means is that it's in quadrant 1. Beta, tangent beta at least, is -7/24. Beta is in between 3 pi over 2 and 2 pi, so that means it's in quadrant 4. So the first thing that we have to do is we have to draw these two reference triangles. So check it out. So notice that I drew both the triangles. I drew alpha in quadrant 1. I found the third side using Pythagorean theorem. Beta was drawn in quadrant 4. Since tangent is the opposite over adjacent, I labeled the sides accordingly, and then I used Pythagorean theorem. So now I just need to find cosine A, cosine beta, sine alpha, sine beta. I just need to find those four ratios using my two reference triangles and plug them into the formula. So there's my formula, see? And then I found cosine of alpha to be the adjacent over the hypotenuse, thus 3/5. And then cosine beta. Cosine of beta is 24/25. And then I did the same for sine alpha and sine beta. So I'm using the alpha triangle for sine of alpha to get 4/5, and the beta triangle to get -7/25. And then you just do that math, okay? So if I actually just multiply the two fractions, and then I divide, well, I'm not dividing at all. I'm combining the two. So I'm going 72/125 minus -28/125 gives me 100/125, which is simply 4/5. So I'm drawing two reference triangles. I'm finding the third side in each using Pythagorean theorem. I'm getting my cosine and sine ratios from those triangles. And then I'm simply following what the formula tells me to do. So those were used just using general ratios. You will have problems where you have to use exact values at special angles. So you may want to use your reference angle diagrams to help you with what are these special exact values. Okay, but we're still using the same formulas. So sine of 2 pi over 3 plus pi over 4. I'm going to draw two reference triangles, one for 2 pi over 3, which is going to be 2 pi over 3 is my 60-degree reference angle in quadrant 2, so I'll want my sines to match accordingly. And then pi over 4 is right here. It's a 45-degree reference angle in quadrant 1. So I'm going to draw those out first. So check it out. Okay. So I've got my 2 pi over 3 triangle going on in quadrant 2. I got my pi over 4 triangle going on in quadrant 1. Now, sine of a sum, so of alpha plus beta, expands to be this. That's the formula. Sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. And so now I'm just going to get the ratios from the triangles. So sine of alpha, so sine of 2 pi over 3 is the square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2. Then I'm finding cosine of 2 pi over 3 is negative 1/2, and sine of pi over 4 is the square root of 2 over 2. Then I'm simply doing the math. So I'm going to multiply my fractions together, and then I'm going to add them. And since I can't combine the square root of 6 and the square root of 2, I'm just leaving it as the square root of 6 minus the square root of 2 all over 4. So once again, draw your 2 reference triangles, one for alpha, one for beta. So in this case, one for 2 pi over 3 and one for pi over 4. Get your sine and cosine ratios from those 2 triangles, substitute them into the formula, and then do the math. And so we can do similar problems involving inverses. So when we draw our reference triangles, we just want to make sure we're in the proper quadrant. So cosine inverse of 1/2, since cosine inverse is positive in quadrant 1, I'm going to draw a triangle in quadrant 1 for sine inverse of 3/5. Once again, is positive, so that one is also in quadrant 1. So let's check out my triangles. Okay. So here are my 2 triangles. I drew the cosine inverse of 1/2, that's representing alpha. Sine inverse of 3/5 is beta. And I am finding sine, like if you look at this, I'm finding sine of alpha plus beta. And sine of alpha plus beta looks like this. That's my formula. Okay, not doing anything fancy there. I just wrote the formula down. Now I have to find all my ratios. So I found that sine of alpha is the square root of 3 over 2. And cosine of beta is 4/5. Cosine of alpha is 1/2 and sine of beta is 3/5. And from there, I'm just doing the math. So, whoops, I'm multiplying first and then adding the 2 fractions together. Once again, I can't really add 4 root 3 and 3 together, so I'm just leaving it as 4 root 3 plus 3 all over 10. So in order to use sum and difference identities, you need 2 reference triangles, one for alpha, one for beta. From those reference triangles, that's where you're going to get your sine and cosine ratios. So find the ratios, plug them in, do the math, and that's how you find exact values using sum and difference formulas. And that's how Backer breaks it down.